Hey everyone, what's up? So, welcome to the new video, and in this video we are going to see the graph of some basic functions. As we have entered class 10th, 11th, 12th, or you are preparing for JEE, no matter, these are the some basic graphs which everyone should be knowing in order to take further their preparation of JEE or board. So, some basic graphs we are going to learn about, and like the trigonometric one or the exponential, square function, odd function, and we will also be knowing in this lecture the uh, domain and range of graphs, how we can draw the graph, how we apply the limit to find out whether the graph will go to infinity or not. There we'll talk about the asymptotes, the graph cuts which axis where, and everything about the graph we are going to learn in this lecture. This lecture will be from basic to the most advanced level, and each concept will be from the very basic one. So let's get started. So firstly, we will be going through the some basic ones, basic graphs. First of all, we have the identity function. You know what is identity function? Identity function is that function in which whatever we give the input, the same output comes as the result. That is y equal to x. This is the identity function. When y equal to 1, x is also 1. When y equal to 2, x is also 2, and so on. So how we will sketch the graph for this function? This function is basically a straight line. Okay, when we draw the graph of this function, this is basically a straight line of what? Y equal to x. So in the previous one I told you how to draw the straight line. We basically use the slope intercept form, that is mx plus c. This equation mainly we use to draw any line. So by comparing it from here, we get m is 1 and c is 0. So by taking these two parameters, we can draw the graph as like this. This is origin 0 comma 0. See, y intercept is 0 and slope is tan theta is 1. Theta is 45 degrees, so the tan theta is 1, which is equal to slope as 1. See, slope as 1 is given and y intercept is 0. So this can be the graph of y equal to x. So as you can see over here, the whole x-axis is taken into account. All the points over x-axis are playing role. So domain is R. As well as you can see, the whole y-axis is taken into account. All the points lying on the y-axis are taken in this line, are included in this in drawing this line. So range of the function is also R. So here domain is also R and range of the function is also R. R means real numbers. Okay, now we will next go for square function. Square function. Okay, what is a square function? A square function basically that parabola. Square function means y equal to x square. Okay, y equal to x square, this seems like a parabola. Yeah, it is a parabola. Whatever the quadratic equations are there, the equation in degree 2, they are the parabola. They are the equation of parabola. So this is the most basic parabola, which goes like this. This is the equation of y equal to x square. You can see here, if we put x equal to 1 or x equal to minus 1, the same output we are going to get, that is 1. So this is an even function. This is an even function. If f of x is same as f of minus x, then that is the even function, and the graph of that function is symmetric about y-axis. So you can see the graph of the function is symmetric about y-axis. Symmetric about y-axis means whatever the graph is this side of y-axis, the same graph, the same visualization comes over this side of the y-axis. So y equal to x square is symmetric about y-axis. You can see this is an even function, so it is symmetric about y-axis. And you can see what is the domain. As you can see, the whole points on the x-axis are taken into account. The whole points are playing role while drawing the graph. So domain is R. And what is the range? For range, we see the y-axis. On y-axis, we can see only the points from 0 to this, in this direction, from 0 to this. So range is from 0 to infinity. Range is from 0 to infinity. As you can see, the graph is not below the x-axis, so no point below the x-axis are taken into account. Only the points which are above the x-axis, they are only used in making the graphs. So range is from 0 to infinity. Whatever the values, whatever be the result of this y equal to x squared, that will be only from 0 to infinity. No negative value can come, no negative value of y can come. Whatever x we will put here, only that will get square up, and that will produce only positive values. So the range is positive, so the range is 0 to infinity. Okay, for range we see y, and for domain we see x. Okay, so another one which we are going to see, that one is cube function. Another one which we are going to see, that is the cube function. Okay, cube function means y equal to x cube. See here, if we put x as 1 and x as -1, we are going to get the same value but with opposite sign. Suppose we put x equal to -1, we get y equal to 1. If we put x equal to -1, then we'll get y equal to -1. So here f of x equal to negative of f of minus x. Here f of x is just negative of f of minus x, so it is an odd function. So it is an odd function. Odd function means f of minus x equal to minus of fx. Like we put x as x and x as minus x. We get x cube as x, and here we get x cube as minus x. So here f of x is nothing but minus of minus x. So this is an odd function. And odd functions are symmetric about origin. So while when we will draw the graph of this cubic function, it will come as like this. See, this is y equal to x cube. You can see all the points on the x-axis are taken into account, are being used to draw the graph, and all the points on the y-axis are also used. So the domain is r and range of the function is also r. Since domain is r and f of minus x equal to minus of fx, that's why it is called an odd function. And odd functions are symmetric about origin. Symmetricity about origin means that whatever the graph visualization will be in the first quadrant, the same type of visualization will be seen in the third quadrant, and this is the symmetricity about origin. Okay, so the next graph we are going to talk about is the graph of sine function. The next graph we are going to talk about is the graph of sine function. Okay, firstly we should note the domain and range of sine function. Domain is all the real values and range is from -1 to 1. Range is from -1 to 1. It means that sine can have sine x. Sine x can only range between -1 to 1. It cannot take values above 1 and below -1. It can range between -1 and 1 only. This is called the range of the function. So if we are going to get and one more thing, you can see domain is r, and here also f of minus x is same as minus of fx, so it is an odd function. So we can say sin x is an odd function. So since it is an odd function, it must be symmetric about origin. Yeah, it is symmetric about origin. So before drawing the graph, we must know some values of sine, like sine 0 is 0, sine 90 is 1, sine of pi by 4 is 1 by root 2, sine of pi by 6 is 1 by 2. Okay, so we must be knowing these values in order to draw the graph of sine function. Okay, if we take as sine of pi by 3, we can write it as root 3 by 2. So these are some values of sine which you must be knowing in order to draw the graph of sine function. Similarly, if you will find out sine of minus pi by 6, then you will get minus half. If we'll include minus sign over here, then minus will jump out and the value which is given by sine pi by 6 will be half, and one minus sign will be there, so one minus sign will appear here. So like this is it is an odd function. F of minus x is same as minus of fx. Okay, so it is said that it is an odd function. So let's make the graph of sine. This is x, this is y. At 0 we are having 0. Suppose this is pi by 2. At pi by 2 we are having value 1. Suppose this is 0 comma 1. At pi we are having the value 0. At 3 pi by 2 we are having the value minus 1. Then again at 2 pi we are having 0. If we come over this side, minus pi by 2 we are having the value minus 1. Oh sorry, we are having the value minus 1. Then if we go for minus pi, we will be having 0. Then minus 3 pi by 2 we will be again be having plus 1, and then minus 2 pi we will be having 0. So when we will join these dots, then we will get a curve like this. We will get a curve like this. This is basically the graph of sine function. This is curvy in nature, not triangular. It is something like this. It is curvy in nature, not triangular. So from here you can see the domain is R. Domain means all the values of x included while drawing the graph. So all the values of x are included, so the domain of this function is R, and whatever be the ranging value of y, whatever the value on y axis comes, that is the range. So range we can see it is from minus 1 to 1. It is not going above 1 and it is not coming below minus 1. So this can be the graph of sine function. Here you can see sine n pi is 0. Whatever the value of n we will put 0, 1, 2, 3. Sine 0 equal to sine pi equal to sine 2 pi. All the values will become 0. Okay, so now next one we are going to talk about, that is the cosine function. Cosine function, in short we say cos function. Cosine function, in short we say cos function. Okay, let's go for cos function. Cos is an even function. Y equal to cos x. If we put x as minus x also, it will give cos x only. Cos of minus x. Cos of minus x is same as cos x. That's why, and its domain of the function is all the real values, and cos of x is same as cos of minus x, so it is called even function. So it is called even function, and in even function we know that it is symmetric about y-axis. It is symmetric about y-axis. So some values you should be knowing, like cos 0 is 1, cos pi by 2 is 0, cos pi is minus 1, and cos 3 pi by 2 is again 0, and cos 2 pi is again 1. So you know it is repeating the value 1 0 minus 1 0 1. It is just like oscillating. It is oscillating between 1 and minus 1. So same graph we can draw for cos also. Only the difference is that it will be symmetric about y-axis. So we can draw it like this. This is the x-axis, this is the y-axis. 0, pi by 2, pi, 3 pi by 2, and 2 pi. Minus pi by 2, minus pi, minus 3 pi by 2, and so on. At 0 we get value 1, at pi by 2 we get 0, at pi we get minus 1, then again 0, then again 2 pi 1. So its graph seems something like this, and the same graph is repeated over here also, because this is symmetric about y-axis, so we get it as like this. So this is the graph of cos x. Here again you can see the domain is R and the range is from minus 1 to 1. Okay, the next graph, that is the most important one, that is of tan x. Graph of tan x. Okay, let's see the graph of tan x also. Then we will see the graph of exponential and logarithmic function. And for the other three graphs you have to wait for the next lecture. Okay, y equal to tan x. See, tan x is not everywhere defined. Why is it so? tan x is basically sin x upon cos x, and it should not be equal to 0 because it is in the denominator. So cos x should not be equal to 0. Now where are the point where cos x becomes 0? At this point. This is the line where cosec x becomes 0. And what is this line? Pi by 2, 3 pi by 2, 3 pi by 2 plus pi, so which is 5 pi by 2. Then again this is 5 pi by 2 plus pi, 7 pi by 2 plus pi, 9 pi by 2, again plus pi, 11 pi by 2, 11 pi by 2. So you can see that odd multiples of pi by 2, at odd multiples of pi by 2, cos is becoming